Okay, we're going to have a look at simplifying this logical expression. We're still going to be following the 3 steps that we're used to, that you can see in the top right hand corner. But first of all, we're actually going to multiply this out, just as you would with any algebraic expression. Makes it easier for us to work with. So this actually turns into, when multiplied out, this. And when you have not A and A, those 2 expressions cancel each other out, so we can just forget that. So that's actually a lot more straightforward for us to work with already. And we're going to invert the whole expression, which just involves removing this not bar from the top. So that's just going to leave us with not A and not B. Then we invert the individual variables, so A and B. And then finally we're going to change the logical connective, so it becomes A or B. So this, simplified, actually just works out as A or B. And if you don't believe me, we can move on to check this in a truth table. So I've drawn up a truth table with all of the different sort of component parts of this expression that we'll need. So if I fill in the values for A and B, all of the possible values that A and B could take. Then I can work out these columns now, so not A, not B. And this is where it gets a little bit more complicated, but it's still not beyond anything that we've done. A or not B. So A or not B in this case is 0 or 1, which would be 1. And A or not B here would be 0. A or not B here would be 1. A or not here would be 1 as well. Okay. Then the next column takes that column that we've just done and says and not A. So 1 and not A here would be 1, but here would be 0, 0 and 0. And then this final column is just the inverse of the column that we've just done, so it becomes 0, 1, 1, 1. So this column here that we've just filled in, the column that represents this whole expression, is the same as the truth table for A or B, because we know that A or B, 0 or 0 is 0, 0 or 1 is 1, 1 or 0 is 1, and 1 or 1 is 1. So that proves to us that those 2 expressions are equivalent, and it's always worth checking once you've simplified an expression using De Morgan's laws, just checking using a truth table to see whether what you've worked out actually does make sense.